Okay, we have time for a few questions.
Well, yeah, it's interesting to see a decent analysis of a gravitational lens optics. Every year, pretty much at the IAF Congress, Claudio Maccone continues to push the idea of expeditions to gravitational lenses. And when I first looked at his and did the analysis that you did, I did the same analysis, but apparently came up with opposite conclusions, because my conclusion was that the optics shows that there's really nothing useful to do with the gravitational lens, simply because the classical optics magnification factor is so huge that 1 second of arc at the telescope here is 260,000 miles. So essentially you make a telescope that is really not pointable. If you want to point 1 second of arc further away, you have to go 260,000 miles. So it's mostly only useful if you know where your target is already. So it's not useful for a search. It might be useful for receiving vast amounts of data once you knew where to point. The pixel size that you analyze is also a problem. It's not really good for a beacon because, as you point out, the pixel size is 2,000 kilometers, but the Earth is 150 million kilometers away from the sun. If they were rastering over our solar system saying, well, there's a planet there somewhere, they would never hit us on the average. You have to already know where you're aiming at before you can use it as a beacon either.
They would hit us very infrequently.
Very, very infrequently. Something like 1 over 1,000 squared or 150,000 squared. So essentially a very small fraction of the time. And of course they have millions and possibly billions of stars that they also want to raster over. So your calculation for communication seems to make sense. It might be a good way to communicate, although you have to note that you're pointing your antenna directly at the brightest object in the sky. You're pointing directly at the sun, and you're pointing directly at the sun with a very high angular resolution. But it's probably not useful for SETI, for searching.
It's very difficult for this raw search. However, they won't have just one receptor. They're going to put up as many as they can afford. So you can envision having perhaps 1,000 up there all working as independent telescopes.
1,000 is a small number. You want a billion.
Yeah, well, yeah, I'd rather. I'm just being a realistic.
As always.
We can't afford more than 1,000 of these. And the point about the communication thing, well, that can be made to work because the receiving spacecraft, once it finds a beam, can track it. So the transmitting civilization probably should just fire straight at the star. And the receiving civilization will put their receiver on that line of sight. They should quickly find the beam, and then the beam needs to be continuous. And then they just track it, and then you've got a permanent good connection.
Paul. Yeah, I think your lenses are really cool, but I guess I want to ask the same question that I asked yesterday publicly, which is, what happened to beacons? 50 years ago, we were quite happy with a megawatt on an Arecibo talking to another one. And why shouldn't we be looking for that kind of thing?
Well, we should be looking for that too. Yeah.
Right, but that means the extinction of our large radio signature is in fact a good thing because it reduces backgrounds. And certainly putting a bunch of Arecibos or a phased array and kicking a megawatt here and there to aim at target stars is cheaper than, at least in the short term, and putting something at 500 AU. So in fact, isn't the rosy future starting right now rather than 100 years from now?
There's a rosy future right now. This is just rosier.
So Joe and Jack have made comments about leakage and how it is now, and now Frank has made many more comments about it. And I just wanted to announce publicly that I think I've become committed, that it's been in the back of my mind for many years, that after a third of the century, I'm going to update exactly what is happening with the current radio signature of the Earth.
Somebody needs to do that because there's really no information. We don't really know the inventory of transmitters of various powers for the world.